Alright guys, it's Alphonse Murungaru and I'll be talking to you today about my Nessus assessment scan on Miss Lacey Hester's Windows and server and Linux servers. We set our assessment to be conducted on Wednesday, on November the 18th at 7 p.m. We met up together in the ITS lab in the business building. We ran two scans, a credentialed scan and a non-credentialed scan. Both the scans on the Linux and the Windows servers, we conducted them at the same time on the same day. Like I said earlier, the servers that I scanned were belonged to Lacey Hester. The Windows scan took 15 minutes to scan, and the Linux scan took 8 minutes to scan. The tools that we used to scan, we did an Nessus scan, which ran on Kali and in the NetLab environment, which has been given to us by our professor. The scope of the test that we did was our vulnerability assessment scan, which was supposed to assess how secure the services that we had been told to pre-install earlier. After we went through a process of hardening them, we had to do this scan and make sure that we had hardened them enough for them to be able to face any attacks from the outside world. We did the scans and we went through the report together to see if we could be able to help each other out depending on whatever issues that came up on the report from the scan. We gave each other recommendations. If we had, let's say for instance, we had issues that some other people that she did not have, I was able to help her, and if I had something that I had not figured out on my scan and I didn't have it, she helped me. An Nessus scan is what we refer to as a vulnerability assessment type of test. I'll be talking about the services that were required to be pre-installed in the boxes, both of the boxes. I'll be talking about if there were any operating system security issues that were discovered by the Nessus scan where it was ran, and I'll be talking about the issues that were most prevalent in both of Lacey's Windows and Linux boxes. And lastly but not least, we'll have a quick review again on the tools that we used during the scanning process of our servers. For the Windows 2012 R2, we were supposed to pre-install the Active Directory, and then you're supposed to install the ADLDS, which is LDAP, which you install on the same place as you are pre-installing the Active Directory. And then we had to install the DNS. The firewalls, it was not installing, but we had to configure the firewalls. They're already pre-installed in the system, but you had to configure the firewall through the group policy and through the Windows firewalls. We also had to install the services, so say HTTP and HTTPS, and we had to install the mail relay SMTP. We also had to install Emmet 5.0. The required CentOS services were we needed to install Postgres or another database. It could have been either Postgres or MySQL, whatever we decided. Each of us had decided to. We also needed a DNS port 53. We needed to install Samba. We also needed to install the open source Dovecot, which has IMAP and POP3 in them. We also had to install HTTP and HTTPS and configure the firewalls at the firewall D or IP tables. So I had to install LDAP into the system, just like the Windows server. And we also needed an SMTP for the mail and SC Linux. After I ran Lacey's scan, I did not find any operating system issues, but I did recommend to her that when you're running systems like a Windows system server, or you're running an environment like a Linux server, it is important that you do constant updates on the systems, because one thing we realized when you're working on our Windows servers was that some of the issues that we kept on having on our Windows servers when we were doing our scans, it will tell us that we are lacking certain patches, and that problem was easily solved just by downloading updates into the Windows server. So I told her how to do it, and the way we figured out how to do it was there's two ways. You can either download the patchings straight from the Microsoft website, and then download them, and then set them up on your system, into your system, or you can right click on the start button at the bottom left corner of the system, and you can do a system update. You can do updates on your computer. And for the Linux box, a little bit easier. All you need to do, you need to run a command yam update, and it will update all your systems for you. For the application security issues, she has quite a few, and one thing I noticed that we had very similar issues, where most of our issues were mostly digital certificates. What I mean by that is that these were issues such as certificates on the POP3, SSL certificate issues on the POP3, LDAP, the SMTP, HTTPS, and also there were also other issues with like things such as the use of RC cipher, and she also had a key bit that was less than 2048 bits. On the HTTPS, I did find on her system on the Nexus scan that her SSL version 2 and 3, she had an issue with the SSL certificate, which had a wrong hostname, and another vulnerability that was discovered was that an SSL certificate could not be trusted, which had a huge base score of a 6.4, and also the use of RC4 ciphers was another problem she had. The recommendations for the HTTP, I recommended edit the configuration file and set a host name. I recommended to install a mode SSL, where you edit the configuration file through VI, or you can do a sudo nano. Either of them should work, I think, or a vim, and you get into the /etc /httpd configuration file, SSL configuration file, and then you then edit the SSL protocol to SSL protocol TLS v1.2, and then you can also edit the SSL cipher suit to SSL cipher suit high. You can also edit the hostname using the hostname CTL, set hostname, and then you can name the host, or you can do a hostname CTL set hostname to delete an old name. And then for the changes that you made to work, you would have to restart the services. And also for another issue she had with the bit key that was less than 2048, you could run a command open SSL REQ new key RSA 2048 hyphen nodes hyphen key out server dot key out server dot CSR with the server, and this will bring the name of the server that you're trying to install this, and then a prompt will ask you for a common name, and then you create a file called an OpenSL.cr. For the DNS, she did have an issue with her DNS server cache snooping, remote information disclosure. The issue that she had with this was that the problem with DNS cache snooping is that DNS remote servers tend to be very vulnerable to DNS cache type of attacks. How this happened is where this type of attack is usually done through the process of seeking to compromise the queries which the DNS stores in the recursive server. This can be done by hackers who use two policies. They can use the non-recursive query, or the type of attack is considered to be the easiest way to attack a system, or the server will issue a reply from a client saying that the snooper needs to send a recursive query. And if the answer that the snooper is interested in is in the server, it will provide that to the person, and that would be considered a compromised system. The other way you can do a DNS cache snooping, you can do very similar to the process above. You exploit how long it takes to respond and the answers given by the TTL. The recommendations that I gave for fixing this would be to edit the configuration file. Again, you can either use VI, you can use Vim, and then you get into your named configuration. You edit the line, scroll down and look for the line that says recursion. It should be yes. Switch it to recursion no. And for these services to kick in and take charge, you would have to restart the services. Another problem she had with the DNS again was in her Linux server, where she had a DNS zone transfer. What a DNS zone transfer will do, DNS transfer will permit zone transfers. Attackers take this chance and they do populate potential targets on the system. This can also give the attacker hints to, let's say you have an organization, and let's say you're primarily the application which this will put your organization in such great risk. The DNS servers are very vulnerable to exploitation and can be used for cache poisoning or DNS spoofing. How to you protect yourself from this, the recommendations for a Linux box, you need to restrict the zone transfers with the IP address. You need to define their access control lists in the name configuration file and apply the IP addresses allowed into the zones. For the SSH, the two biggest issues on the OpenSSH or the server CBC mode cipher were enabled, and there were weak algorithms in the SSH. The recommendations will be to edit the configuration file. You need to get into your default /etc /sshd configuration file, and you need to look for a file that contains the default AES128CTR or AES256 or ARC4256 to disable the CBC mode prices and the weak MAC algorithms MD5 and 96. In the configuration file, you need to add ciphers AES128 /CTR AES256 ARC4128, and then you need to do a max HMAC SHA1 UMAK, and you need to put in your OpenSSH in between there, and then you do a HMAC, and then you do a RIPE MD160, and then for the system to kick in and to start working the way you want it to, you'd have to restart after you have made the changes, and you can do a stop SRC, -s space SSHD, and then you can do a start src space -s space SSHD. And to test if that your new configuration is working, you can run a SSH space hyphen VVV space -F. For LDAP, the Nessus scan gave us one vulnerability, and the recommendation was that we needed to disable SSL v2 and disable SSL v3. The recommendations will be for you to edit the SSL .conf and add the following entries: SSL cipher suit space high colon SSL LV2, and so on and so on. And then you need to restart the network for it to work, to see, so that if you see the system is working. And then to check if S2 is disabled, you can run an open. You can run a command that goes open SSL space S client space hyphen connect, and then you put the host name, or the host name will be your server name. The other important thing to note will be on the vulnerability ranking scale, it ranks on a CVSS score, which is the base score. What a CVSS means, it means Common Vulnerability Scoring System. The scale runs from 0 to 10, which 10 is the most critical, and then you have critical, and then you have medium, and then you have low, and then you have information being 0. The base score never changes. That's one good thing to note. The tools that we used, I'll reiterate, I ran a ZenMap before we did a scan to see if all the ports were open and if all the ports were running. We ran the Nessus scan, which is the vulnerability assessment scan for the whole scan, and then we ran a basic network scan on the services, both the Windows and the Nessus and the Linux. And that'll be it for my presentation. These are my references. Thank you very much.